Hello everyone. Welcome to the solution of LeetCode problem 234 named Palindrome linked list. In this problem, we are given a linked list and we have to determine whether our linked list is palindrome or not. Suppose let's consider the first example. Here, the linked list are 1, 2, 2 and 1. So we can say that 1, 2, 2 and 1 are palindrome because first one is equal to the last one and second two is equal to the third two. So it is symmetrical or palindrome. But in the second example, we can see that the first element is 1 and the second element is 2, but both of them are not equal. So they are not palindrome. Anyways, now let's understand the constraint. Here, the number of nodes in the list can be in between 1 to 10 to the power 5. And each of the value presented in node can be in between 0 to 9. I hope you understood the problem. Now let's move on to the explanation of the solution. Before jumping into the solution, I want to explain the linked list a little bit. In the linked list, every node is connected with each other. Suppose this is node 1, which is connected to node 2, and node 2 is connected to node 3, and so on. Here, each node contains two values. One is the actual value presented in the node. Suppose it is 5. And in the second position in each node contains the memory address of the next node. So in this node contains the memory address of next node. Again, for this node, it has also two values. First one is the value, suppose it is 6. And secondly, this node contains the memory address of the next node. So basically, this is the working procedure of the linked list. And finally, the last node will point to null. I hope you understood the basic idea behind the linked list. Now let's move on to the actual solution of this problem. Now consider the first example. In the first example, there are 4 values presented in the linked list. The first node is 1, the second node is 2, the third node is 2, and the final node is 1. So we can say that this is the palindrome because the value contains the first node is equal to the value contains last node, and the value contains second node is equal to the value contains third node. So as the corresponding value are equal, so we can say that this linked list is a palindrome. But what is the mechanism to solve this problem? Using data structure. And there is an intuition. Basically, when we are given any palindrome related problem, or we have to validate a linked list or a string is a palindrome or not, we have to use the stack data structure, because by using a stack, it is relatively easier to determine whether our current input is palindrome or not. The main mechanism is I have to use one extra stack, which is this, and we have to serially insert the linked list value into the stack. Suppose this is our stack. At first, our current pointer pointing to the first element. So we have to put the value presented in the first node, which is 1, into the stack. Now, our current pointer is pointing to the next element. So we have to put the value of 2 into the stack. And now our current pointer is pointing to the third element. So we have to put the value of the third node into the stack, which is 2. And finally, our current pointer is pointing to the last element, which is 1. And we have to put the value of 1 into the stack, which is this. So this is the condition of our stack at this moment. Now the algorithm is, at first, our pointer is pointing to the first element of this linked list, which is 1. And we have to check whether the top element of the stack is equal to the value pointing to the current element. So we can say that the top element of our current stack is 1 and the pointer value is also 1. So both of them are equal. So in this case, we have to remove the top value of our stack and upgrade our current pointer to the next node. Now our current pointer is indicating the second node. The value of this node is 2 and the top position of our stack is also 2. So in this case, we have to again remove the top element and upgrade our current pointer. Now our current pointer is indicating the third element, which is 2. And the top position of our stack is also 2. So in this case, both of them are equal. So we have to remove the top element of the stack and also upgrade our current pointer. Now our current pointer is indicating the last element and the only remaining value in the stack is 1. And fortunately, both of them are equal. So we have to upgrade our current pointer and also remove the 1 from the stack. Now our current pointer is indicating to the null. But wait, our stack become empty. So we are clearly noticing that if our current linked list is palindrome, by using this algorithm, we can make the stack empty. So we can say that if in any iteration, the top element of our stack is not equal to the current pointer value, so we can say that our linked list is not palindrome. Suppose there are lots of value in the stack. The top element of this stack is 2 and our current pointer is indicating this last one. But wait, this one is not equal to the top element of the stack 2. So in this case, it is not possible for the linked list to become palindrome. So in the algorithm, if in any iteration, our current pointer value is not equal to the top value of the stack, then we have to return false. Otherwise, we have to return 2 after the completion of the iteration. So by applying this algorithm, we have to determine whether our current linked list is palindrome or not. I hope you understood the algorithm. Now let's move on to the code. In the code, at first we are given a function is palindrome, which is given a linked list in the parameter, and the return type of this function is Boolean. If our current linked list is palindrome, we have to return true. Otherwise, we have to return false. At first, we are checking that our current linked list is empty or not. If our current linked list is empty, then by default, we have to return true. Otherwise, we have to take a stack to store the value presented in the linked list. And our current pointer is indicating the head node, which is the first node of the linked list. And by using this loop, we have to serially input the value presented in the linked list to the stack. After inserting, we have to again repoint our temporary pointer to the head element or to the first element of the current linked list. And finally, we have to run a while loop. You can perform any loop, but a while loop seems easy to me. Anyways, in each iteration, we will check whether our current pointer value is equal to the top position of the stack. Or we can say that we have to check whether our current pointer value is equal to the value presented in the top of the stack. If it is, then we have to remove the top element from the stack by using the pop function, and we have to update our pointer to the next element. Otherwise, if both of them are not equal, then it is not possible for a linked list to become a palindrome. So we have to return false. Otherwise, if we completed the while loop without returning false, that means our current linked list is palindrome. So finally, we have to return true. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this code, the time complexity is big O of n because we have to iterate the entire linked list twice. So If we consider n is the size of the linked list, so our time complexity will become big O of n. And our space complexity is also become big O of n because we are using one extra memory for the stack. And for this algorithm, the size of the stack can be equal to the size of the linked list. So we can say that the space complexity of this algorithm is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.